So let's start the next paper, paper number 9, Empowering Healthcare with Cyber-Physical System, a Systematic Literature Review. So in this paper is discussing about the use of cyber-physical systems in healthcare sector. Basically, the journal name is IEEE Access. Paper number 9, Empowering. So this is an international research journal from IEEE. These this journal, they are publishing high quality journals related to engineering, AI, healthcare, robotics, IoT, automation, etc. So this is a survey paper. Survey paper means this is not an experimental paper. This is actually studying previous papers and comparing and then giving a summary. That is what is called a survey paper. So this is basically a survey paper. The title explanation is, empowering healthcare with the cyber physical system. That means how we can convert the healthcare sector into more intelligent, automated, fast, and safe with the help of cyber physical system. The authors are Heba M. Khater, Farag Salabi, Mohammad Adel Serhan, Ezdin Barak, Khalid Suhaib, Asdullah Tariq, Muhammad Khayal. They are working in different universities such as United Arab Emirates, University of Sharjah, Zagazig University, etc. Coming to the abstract, so this is a small summary of this paper. In this paper, they are explaining that this cyber physical systems are very quickly growing in healthcare sector. CPS, what do you mean by CPS? First of all, we should understand what is CPS. CPS means cyber physical system. That means we have computer systems, we have physical devices, and all these computer systems and the physical systems are connected. Are connected. So there will be a communication network to connect these computer systems and physical devices. All these intelligent systems, all these systems are converted into an intelligent system. This is what is called a CPS, cyber physical system. For example, we can think about smart hospital systems, remote patient monitoring, smart ICU, IoT healthcare devices, wearable sensors. These are examples of cyber physical systems. In this paper, they are explaining that the integration of physical and the cyber world. We have a physical world plus we have a computer world, right? Or the cyber world. So with the help of sensor, that patient data will be collected and that those data will be analyzed by the software, and then based on that, it will take automatic decisions. The main advantage is that real-time monitoring, such as monitoring the heart rate, blood pressure, oxygen level, temperature of the patient real time. So through this, we can improve the Through the cyber physical system, we can improve the healthcare quality, such as fast diagnosis, better treatment, reduced errors, continuous monitoring. Everything will be possible. IoT means everything. Every devices will be connected through internet. So that is what is called IoT, Internet of Things. You can think about smart watches, fitness bands, wireless glucose monitor, a smart thermometer, etc. Another point is that utilizing the AI support, artificial intelligence support, with the help of AI algorithms, by analyzing the patient data, we can predict the disease, we can predict the risk, and also treatment also we can recommend. In this paper, they are also discussing about some challenges, such as the one of the main problem is security issues, patient data hacking, because all these devices systems are connected through internet, right? So there is a possibility of patient data hacking. Another problem is that patient privacy problems. So in some cases, the medical records can leak, so that will create privacy issues. High cost. This is a part of advanced healthcare, so the cost is too much to implement this system, and this is complex. The complexity, because we have different systems integrated each other, so the system itself is too complex. So these are the challenges mentioned in this paper. The main keywords explained in this paper was cyber physical systems. That means the integration of physical devices and software. Healthcare is related to hospital, patient care, and medical systems. Real time processing, discussing about once the data will be collected, immediately processing those data, called real-time processing, and all the devices connected through internet, called Internet of Things. In the introduction section, discussing about the monitoring, communication, automation, and decision making. uh, you know uh, Patient condition will monitor continuously, and all these devices will be communicating properly. So there will be a data exchange between all the devices, and the main objective of the cyber physical system is to reduce human intervention, and automatic system will work. With the help of AI and software, we can take intelligent decisions, so decision making is very much possible. Smart hospitals, we can think about modern hospitals, such as the hospitals will be using sensors, IoTs, AI. That means the hospital will be having smart beds, automated medicine delivery, and digital monitoring. Remote patient monitoring is another important thing related to the advanced healthcare, modern hospitals. That means even though the patient in the not in the hospital, even though the patient is in the house, the doctor can monitor the patient, right? So for example, the smartwatch heart rate will send those information to the hospital. Wearable devices, this is another example. So this is a part of smart electronics where the patient can wear into their body, such as smartwatch, ECG patch, fitness tracker, etc. Emergency systems, if some emergencies will happen, the doctor will get an automatic alert. That is what is called an emergency system. So we need technologies to incorporate to run this system, such as sensors, such as to measure the physical data. We need sensors. For example, we need a temperature sensor, ECG sensor, motion sensor, etc. In order to store the data to the internet server, we need cloud computing. We need artificial intelligence, machine learning, and intelligent prediction systems. And we have a large amount of data because we have a large healthcare sector. We have larger data sets. So to analyze those, we need the big data analytics. The benefits of CPS system means with the help of artificial intelligence, we can detect the diseases early. The accuracy will be better. Monitoring 24 by 7 patient monitoring, we can reduce the for hospital visits because of the remote monitoring, frequent visits not required, and because of the emergency detection, the patient safety will be improved. The future scope will be AI-based hospitals, smart robotic surgery, digital twins in healthcare, autonomous monitoring systems, intelligent ambulance systems, etc. So the overall understanding of this paper is that nowadays hospitals will be converting into, they are in the path of modernization. So through this, the life of patients will be improving. Automation will be introducing into the hospitals, and integration of AI will helps the doctors to treat the patients very effectively comparing with the previous case. Remote healthcare is possible. So this CPS system, this is we can say this will be the future technology in healthcare by incorporating IoT, AI, sensors, cloud computing. We can convert the hospitals into smart, safe, intelligent, efficient, etc. But still, we have some issues such as security, privacy issues, cost. So we have to solve all those issues. So in the second page, so we have a total 42 pages. So in this second page, this is mainly explaining the cyber physical system. So how this cyber physical system is working and what are the advantages of healthcare. So we have a simple, you know, CPS basic structure. This image, this figure represents the basic structure of cyber physical system. The main components of cyber physical system will be, we have a cyber world that consists of, that means this will be the digital representation. For example, this sector is consisting of computer systems, softwares, communication networks. All these comprises to form what is called a cyber world. That means we need computation, communication, control, everything will be happening in this world. In the physical world, we have our real devices, such as we have sensors, embedded systems, actuators, etc. Right? So this picture represents the structure of the cyber physical systems. In the physical world, we have sensors, right? So what is the objective of sensor? The main duty of sensor is to collect data from the physical environment. For example, heartbeat sensor, temperature sensor, right? Blood pressure sensor, oxygen sensor, etc. So the sensor will collect the data of the patient in this healthcare sector. The uh, the sensor will collect the data from the patient and it will directly send to the sent to the computer system, and the AI software will analyze those data. We have embedded system. Embedded system means smart intelligent computer systems that will process the data, device control and automation. For example, smart insulin pump. Actuators means the system that will convert computer instructions into physical actions. For example, automatic medicine injector, smart wheelchair movement, robotic surgery arm, etc. So actuator means this will convert the computer instructions into physical actions. So we have two arrows mentioned in this diagram, right? One is observe and another one is control, right? So this is a cycle actually. So observe means the cyber world. That means this system will observe the data from the physical world. That means the data from the physical world will enter into the cyber world, right? For example, patient heart rate monitoring. And in the control, then based on the data is received from the physical world, this cyber world will take appropriate action. That means control, take appropriate decision, and then based on that it will control the physical device. For example, if the oxygen level is low, it is detected, then what will happen? Then it will activate the alarm, right? So this is like a cycle: observe, control, cycle. The CPS working process will be the sensor will collect the data, and then through the communication network, it will directly send to the software. And inside the software, AI algorithms will analyze the data, and the system will take appropriate decision. And based on that decision, the actuator will perform. So this in this paper basically explaining the CPS system is using in transportation, energy, healthcare, manufacturing, etc. So the advantage of CPS will be real-time monitoring. That means the system will immediately react, right? And another one is that we can reduce human effort with the help of CPS system. Because of the automation, we can reduce the manual work. This will give more efficiency and also improved safety. The healthcare application section will be the use of smart devices, such as we can connect the healthcare devices to the internet. For example, smart ECG, smart ventilator, smart ICU systems, continuous monitoring. That means 24 by 7 patient monitoring is possible. Remote healthcare is another advantage. The doctors can remotely monitor the patient. In this paper, they are mentioning about COVID-19 situation. Uh, During this COVID-19 situation, the importance of CPS was increased because that COVID-19 situation, remote monitoring is more than the other situations, right? The hospital becomes overloaded during this situation. Contactless healthcare is required at that time. So during this COVID-19 situation, the importance of CPS was introduced because of remote monitoring. Hospital becomes overloaded and contactless healthcare was required. During the COVID-19 situation, remote monitoring was required because the patients will be inside their room and the doctor will monitor the patient through this system. So, during that COVID-19 situation, because of some rules and regulations from the government, the people, they are not able to go outside, right? So because of that, the physical contact will be very less. Okay, so the doctors can treat the patient without any physical contact. And because of the CPS system, we will get the patient data quickly, so that the doctor will take appropriate result based on the analysis. The main objective of this paper is to conduct a literature review, such as analyzing the existing papers, and in order to understand the technologies such as AI, IoT, sensors, embedded systems, etc. What are the challenges? What are the challenges this CPS systems facing, such as security, privacy, complexity, etc.? And also, this paper is suggesting some future smart healthcare systems. The important technical terms mentioned was computation represents the data processing and calculations. So all the devices are connected and there is a proper communication, there is a proper data transfer between these devices. Automatic system management control, dedicated mini computer device, meaning embedded system. In cyber physical system, this will be converting the healthcare into a smart healthcare environment by connecting all the physical devices with the computer intelligence. Because of that, the patient monitoring, automation, remote healthcare, emergency response, intelligent diagnosis becomes more efficient. So healthcare will be the future of healthcare will be mainly technology related. So we can incorporate sensors, IoT, AI, embedded system. Everything will be combined and converted the present hospital systems into smart, automated, intelligent systems. So this was getting more importance because of the COVID-19 situation. So coming to the next page, page number 3. This is explaining the CPS components. What are the different components of a cyber physical system? So the different, what is the use of cyber physical system in healthcare? Then what about the healthcare building blocks and taxonomy of CPS? We have a figure that is representing the components of cyber physical systems. Mainly, this consists of computation, right? So what is the use of computation here, where the data processing is happening, such as the calculations, AI processing, data analysis, decision making, etc. For example, here the patient ECG data will be analyzed in this computation area. We have sensors, right? So what is the use of sensor? The sensor will collect data from the physical world, the information. Sensor will collect the information from the physical world, for example, temperature sensor, heart rate sensor, blood pressure sensor, etc. Then we have actuators. So actuators, the duty of actuator is to change the computer decisions into physical actions. For example, smart injection system or the robotic arm will move from one location to another, alarm activation, etc. So we have a storage, right? So we have a large amount of data or informations related to patients. To store those informations, we need a storage system. For example, cloud storage, hospital servers, or medical records. So the storage is dealing with the patient information store the information related to the patient medical records. Then we need communication. So we have different devices. So there will be a proper communication between all the devices. So there will be a proper data transfer is required through Wi-Fi or Bluetooth, internet, 5G network, etc. So all these systems are interconnected. So this all these systems will working together. That is what is called a cyber physical systems. So everything will be connected. All these devices are connected. So the working flow will be like this. We have sensors collect the data, and through communication, the data will be shared to the computation. Then based on that, it will take appropriate decision, and finally it will be shared to the actuator, and the actuator will move accordingly based on the decision. So what CPS in healthcare section, meaning the cyber physical systems, how the physical devices and the software systems will integrate in healthcare. That is what is called a CPS in healthcare section. This is a smart technology where the physical devices and software systems will integrate. The main purpose of this CPS in healthcare sector will be to convert the healthcare services more faster, smarter, safer, and automated. This paper is also explaining the advantages of healthcare. So we need to provide accurate services because of the cyber physical systems, we will be continuously monitoring the data, right? So because of continuously monitoring data, we can provide accurate services. Timely service delivery, we can detect emergency situations very quickly. Cost will be reduced because of this automation. The operational cost will be reduced, and we will be using smart systems. So we have energy efficiency, right? So scalability, that means we can expand. We can easily expand this system from one level to another level because of the continuous monitoring. The reliability will be increased, so we will get a reliable healthcare. So, what are the benefits of incorporating this CPS systems into healthcare? So, the first one is because of the AI monitoring, the human mistakes will be reduced. So, it will reduce the medical errors, and of course, patient productivity will improve because of this continuous monitoring. Better recovery will be possible. Also, infection spread control by by reducing the physical contact with the help of the CPS system. Remote healthcare is possible. So infection spread, we can control it. Doctors can take decisions quickly. So faster decision making is another advantage of this CPS system. So this figure is representing the working cycle of CPS system. We have different phases called, we have a sensing phase. During the sensing phase, the sensors will collect the patient data, for example, ECG signals, temperature, or oxygen level, etc. And we have another area is called a storage and processing phase. Once the data is collected, the data will be stored in the cloud. So where the artificial intelligence will analyze those data. And we have another area is called monitoring phase. That means that is specialist will monitor it, and we have control phase to control it. So the actuation phase will be representing the system will take a decision from after the processing phase, and it will perform the action. That means, for example, alert generation, medicine control, robotic response, etc. The data flow will be of of three types, such as control flow, then uh, system devices will control it, monitoring flow, and the patient data will be continuously monitored, and there will be a feedback flow. The system results, we can analyze it. So this the healthcare CPS systems are different, divided into different categories, such as appliance. The two main categories will be appliance. For example, patient-centric devices, for example, wearable devices, smart devices, home monitoring systems. What is the advantage of appliance? That means patient-centric devices. Individual monitoring is possible, home healthcare is possible, and low-cost system. And the second one is infrastructure. Infrastructure means we need large healthcare systems, such as we need hospital networks, we need cloud infrastructure, we need centralized monitoring. So the features will be high scalability is possible, centralized control, and hospital-wide monitoring. So different terms mentioned here is cloud computing. So the medical data will be stored in the internet server is what is called a cloud computing. And wearable device, as you already know, the patient can wear those smart devices into their body is what is called a wearable devices. Smart intelligent control system is what is called embedded systems. So we have different systems. So interoperability is required. Interoperability means the ability to communicate different devices. We have different devices. Still we have some challenges. Even though we have so many advantages, still we have some challenges, such as one problem is the security issue. So the patient data hacking is a main problem in CPS system. And the another one is called the privacy issues. There is a possibility to leak the medical information of the patients. And another one is called this system is a highly advanced system, so we need advanced system continuous monitoring, so maintenance is not that much easy. So the cyber in this paper is basically explaining the cyber physical systems in healthcare. That means using multiple technologies and converting the healthcare system into an intelligent healthcare environment. For that, we will be using sensors, AI, communication, cloud computing, and automation. Through all these systems, improve the patient monitoring, remote healthcare, automated treatment, and emergency response will improve. So the in healthcare, this CPS system will be the backbone of the future smart hospital. In the future, hospitals will become smart hospitals. So the backbone of smart hospital is CPS system. So CPS healthcare will be the backbone of this smart hospital. So in smart hospitals, the sensor will collect the data and AI will analyze it, and through communication systems, it will share the data, and actuators will perform the automatic actions. Through this, we can convert our healthcare sector into more intelligent, efficient, secure, and automated. So coming to page number 4, this is basically explaining the CPS healthcare applications and related work or literature review. So healthcare CPS applications, data requirement. What do you mean by data requirement? In healthcare CPS systems, we will be processing large amount of data. For example, we have a biosensors. You know what is biosensor, right? So biosensors are those sensors measuring the body signals, such as ECG sensor, blood pressure sensor, glucose sensor, temperature sensor, etc. We will be using large data to predict the disease, patient monitoring, AI diagnosis, and the emergency detection. So we have large amount of data. So we need big data analytics to analyze the millions of patient records. COVID patient, you can think about the COVID patient monitoring systems. Then we have sensing. Uh, we have sensing means the sensor will detect the physical condition of the patient. We have different sensors such as internal sensor, external sensor, etc. Internal sensor means the devices that can be used inside the body. For example, pacemaker sensor. External sensor means, for example, smartwatch sensors. We will be using outside the body is what is called external sensors. Then we have a large amount of data. Data management is another sector. So once the data will be collected, we have to store, process, and manage it. So to store the data, we need a data storage system. For example, in cloud or server, the medical records will be stored. AI system will analyze the collected data called data processing, and then analyze the data, will evaluate the condition of the patient. So, security, the term security is very important in healthcare because the patient data is a confidential data, right? So everything is connected through internet. So there is a possibility of hacking. So in healthcare, CPS system security is very, very important because I have already mentioned because the patient data is confidential. So the security challenges will be hacking. So medical systems can attack. So hackers can attack the system and take the data of the patients. Then data leakage. So patient record maybe leak. Then unauthorized access. So the uh, people those who are not authorized to access the data, they will unauthorized access the data. Unauthorized users, they will collect the medical data. This is another security issue. Control and actuation that represents the control system will perform the automatic actions. For example, automatic medicine delivery, robotic surgery, emergency alert systems, etc. The purpose of in this related work represents what are the uh, papers, what are the previous papers, what are the studies conducted in previous researches, that will be explaining in this related work area. The purpose of related work is to summarize the studies and comparing different methods such as different CPS technologies and find the research gaps such as to identify the areas to work in the future research. The main findings from the previous studies was different researchers studied CPS healthcare systems in different ways. The important topics mentioned was AI-based healthcare monitoring systems, IoT integration, all the smart devices, healthcare systems connected, cloud computing. So the patient data will be stored inside the online server, and smart monitoring means continuous patient monitoring. The challenges identified in literature was one is privacy issues because of the sensitive medical data protection. We have an advanced technology using, right? So the complexity, because we will be using different technologies, we will be integrating different technologies. So the complexity is another challenge. Verification problems, we have to test the system reliability, right? So how we can verify this system, this is another challenge. Scalability issues means if we will be planning to implement this in large hospitals, that will be difficult. CPS design challenges was real-time operation. The system should work without any system delay. Reliability is required, right? Then accuracy, the medical diagnosis should be accurate. And interoperability, that means we have different devices. There will be a proper communication between different devices called interoperability. So this paper is mentioning security concerns in healthcare system. CPS was considered as a major challenge because All these healthcare systems are connected to the internet, right? So there is a possibility of cyber attacks, malware, ransomware, unauthorized access. So these are the risk associated with this. So from this we can say the research gap. So we have the this from this paper they have identified the research gap, such as there is no standardized architecture in healthcare CPS system, and also there is no complete security solutions, and they have some interoperability issues, and the integration is complex. So these are the research gaps mentioned in this paper. So the future research areas will be identified from this, such as better AI systems, strong cybersecurity, smart remote healthcare, efficient data management. So in healthcare, CPS system means collecting a huge medical data and analyzing those medical data with the help of artificial intelligence and IoT, and providing smart healthcare services. But still, this system is facing security, privacy, interoperability, scalability. The system is facing. So these researchers studied the previous studies, and also they suggested some future improvements. In healthcare, this cyber physical systems will convert the existing healthcare into modern healthcare systems. So this will be the backbone of the modern smart healthcare system. So the sensor will collect all the data and AI will analyze it, and the cloud systems will storage those data, and control systems will perform the automatic actions. But still, the system is facing patient privacy, cyber security, system integration. These challenges, these are the still these systems are facing some challenges. So this coming to page number 5 is mainly explaining previous CPS research limitations and need for better systematic literature review, gap analysis, and CPS in healthcare research directions. What are the existing CPS research problems? This paper is discussing the limitations of previous CPS studies. The main issues mentioned in this paper was modularity problems. So modularity problems, that means um, in CPS systems we will be using different healthcare systems, but that easy integration is not possible. This is one of the main issue. Scalability issue I have already mentioned. Even though small systems will work, but if we scale this system to a large hospital, we will be facing some performance issues. So this is another challenge called as scalability issues. These systems are highly complex. So because of that, we have different systems such as AI, IoT, sensors, cloud, embedded systems. Everything should be integrated. So these systems, we can say this is complex. So complexity is more. The challenges mentioned in this paper was energy flow management. So in smart healthcare devices, they should manage the power efficiently. So energy flow management. Information integration, this is another challenge. That is, we have data from different devices. So combining data from different devices, still, this is a big challenge. So reliability, this is another challenge. So if the system failure will affect the safety, safety of the patient, right? Then another one is the security and privacy. You know, the patient data is highly sensitive and also it is highly confidential. So security and privacy is another challenge. And educational exploration. Some previous papers, the healthcare CPS concepts not explain fully. The previous studies limitations was many research papers will focus on some specific areas. For example, AI only, IoT only, sensors only, cloud only. So the problem is the complete healthcare CPS architecture. There is no paper associated with explaining the complete healthcare CPS architecture. So we need a systematic literature review to organize research. So we have to summarize different papers to identify the research gaps. So we have to identify the future improvements, and also we have to compare different technologies. We have to evaluate the different CPS approaches. We have to in this paper analysis process, the authors analyzed the different architectures, components, applications, and implementation technologies. So the research period mentioned was from 2017 to 2023. So they analyzed papers from 2017 to 2023. So the main observation was of previous reviews was limited scope, incomplete analysis, and partial healthcare coverage. Gap analysis. So in this section, explaining the what are the unresolved issues still the CPS sector is facing. The major gaps identified was uh, lack of unified architecture. So different systems, that means we have different systems using different architecture. So there is a lack of unified architecture. That means there is no standard model. Another one is the security weakness. So cyber attacks will affect the healthcare systems. The next one is limited interoperability. So different systems don't have a smooth communication. So data processing issues is another challenge. So we have a huge medical data. So processing huge medical data is again still difficult. Cloud computing issues because latency, storage, security issues. So edge computing is mentioned. So edge computing means other than the cloud computing, see the data processing will be near to the data source. That is what is called edge computing, because we need immediate response in healthcare. If even though the small latency is not accepted, so there is a problem of latency in cloud computing. So real-time response is required in healthcare. So we need edge computing than cloud computing. So the benefits of edge computing will be faster response, lower delay, and reduced cloud dependency. The CPS applications, I have already mentioned these points, like healthcare monitoring, smart diagnosis, emergency healthcare, pandemic control. The main aim of the author is to classify this healthcare CPS systems, analyze it, compare it, and also suggesting the future directions. So the methodology mentioned was the paper systematically followed and conducted the study, searching papers and selecting relevant studies, analyzing the results, and synthesizing the information. Important technical terms mentioned in this paper was edge computing, cloud computing, interoperability, scalability. In existing healthcare systems, in existing healthcare CPS, we have different gaps. Previous studies, mostly partial analysis, included only partial analysis. So the complete, secure, scalable, interoperable healthcare CPS systems, still it is not fully developed. So by conducting a systematic review and analyzing the current technologies, we need to identify the future improvements. This is very important. So this technology, this healthcare cyber physical system is a technology having a huge scope, but still that system is facing some issues such as security, interoperability, scalability, and unified architecture. So existing research studies will analyze, and the authors will suggest a future smart healthcare systems, and also suggesting a better framework that will give a research direction. So coming to page number 6, basically explaining the previous healthcare CPS research reviews, gap analysis, CPS architecture and technologies, future research needs. In this section, the author is analyzing the previous research papers. The authors, they are explaining healthcare CPS, but the scope was limited. What are the problems identified in previous reviews? Was one is modularity issues. Modularity issues means there is no smooth integration between different modules. And another one is called a scalability problems. So scalability problems means even though the system will work in small hospitals or small healthcare setups, but if we will be implementing this into a big hospital, uh, there the system will be facing some issues. So that is not efficient in a large hospital. So there is a problem of scalability and complexity. These systems basically, these systems are complex systems. So complex system means because we will be utilizing AI, IoT, sensors, cloud computing, edge computing, etc. So everything will be integrated. So the possibility of complexity is more comparing with the other systems. Energy flow management. This is the important challenge mentioned. So in order to run the devices, healthcare devices, the device need power, right? The device need energy. Continuous power is required. So efficient energy management system is required to run the system. Information integration is another challenge. We have different healthcare devices, and we will be getting data from different healthcare devices. So we have to combine those data from multiple healthcare devices. Again, that is very difficult. Another problem is that patient data is very much sensitive, so security and privacy issues, because the patient medical data is highly sensitive. Some papers concepts, they didn't deeply explore the topic. CPS taxonomy mentioned, the healthcare CPS systems divided into different categories. So the different components covered was data management, communication, sensing, processing, control systems. Data management system means we have to, in healthcare system, we have a huge data, we have a huge patient data. So in DMS, that means in data management system, they have to collect the data of the patients, store it, process it, and analyze it. So other than cloud computing, this paper is mentioning edge computing. Edge computing means the data will be processed near the data storage. That is what is called edge computing, because the problem is that in cloud computing, there is a problem of latency, right? In healthcare sector, we need immediate response. So that's why they are mentioning the edge computing method, because of the faster processing, lower latency, and also reduced cloud dependency. So cloud Cloud computing means the patient data will be stored in the internet-based servers. So the advantage of this cloud computing is that remote access is possible, even though the doctor is not in the near to the patient. The doctor can access the data through this cloud computing. And another advantage is that the large storage. We can store a huge medical data in the cloud computing. The CPS applications in healthcare will be medical monitoring. The doctor can monitor the patient continuously, and remote healthcare consultation is possible. AI-based disease prediction, pandemic monitoring. I have explained during the COVID-19 situation. So in the gap analysis section, what are the gaps mentioned in the existing CPS research? The main gap they are mentioning was the lack of unified architecture. There is no standard healthcare CPS framework. So we have to lack of unified architecture. Another problem is that the interoperability issues. That means we have different healthcare devices. So there is a problem of compatibility issues. Another one is called we need strong cybersecurity frameworks because of the security problems issues. And another one is that real-time processing challenges, because we have a large amount of data and we have to process the large amount of data instantaneously. That is very difficult. The author is suggesting summarizing different works such as IoT-based IoT-based healthcare, edge computing, cloud computing, artificial intelligence, CPS security, etc. The motivation of this research was the existing reviews was incomplete. So the main objective is to conduct a comprehensive systematic review. And the main goal of this was to analyze different technologies, identify what are the challenges, and comparing the existing systems and suggesting a future research. The research methodology mentioned in this paper was searching research papers and selecting relevant studies, analyzing the results, and synthesize all the informations. The important technical terms associated with this was edge computing. You know what is edge computing, right? So local processing near devices, and another term is called a latency. That is a major problem in cloud computing. So that's why they are suggesting to use edge computing. We have different devices in healthcare sector. So the systems should work properly. The integration should be proper, but still it is the interoperability is not good. That means the compatibility is not that much good. Scalability means even though the system will work in small healthcare setups, if we will be planning to implementing this system into a big hospital, again, it is very difficult, still facing some issues. The This field is basically, yeah, right now I'm concluding this field is still it's a rapidly growing field. Previous studies mentioning some partial analysis only. So still this system is facing some issues such as we need a standard architecture is required. Then security issues, because the patient data is highly confidential, highly sensitive. We have different devices. Still, there is a problem of interoperability. We will be processing a large amount of patient data, so real time processing again facing some challenges issues. This again not fully solved. So by conducting a comprehensive systematic review, the aim is to suggest some improvements in future healthcare CPS systems. So coming to page number 7. This paper is mainly explaining the PRISMA methodology and paper selection process, inclusion and exclusion criteria, healthcare CPS technologies. So in this picture, figure number 4 is explaining PRISMA methodology. So PRISMA means preferred reporting items for systematic reviews and meta-analysis. In Prisma process, we have different steps. One is identification. In this step, the researcher will collect papers from different databases using different keywords. So, in this area, the main keywords was cyber physical systems, smart healthcare, AI, IoT, cloud computing, big data, etc. So the databases used was IEEE Explore, Scopus, ACM, and Science Direct. The researchers initially they have collected a large number of papers. Then after that, the second step will be filtering or screening. In this stage, the researcher was removing irrelevant papers. That means duplicate papers. So that means same paper will be available in multiple databases. Bases. Also, we have some irrelevant articles not related to healthcare CPS. And then step number 3 will be eligibility. So the remaining papers will be conducted a detailed review. So the researchers checked the abstract, methodology, results, and relevances. And step number 4 will be included. That means the final selected papers will conduct a systematic review. So we have a figure. In this figure, we can see in the initial research, they got large number of papers. After filtering, they have retained relevant papers, and the final review, high quality papers was included. This is what is called a Prisma based SLR methodology flow diagram. Coming to the inclusion and exclusion criteria. So that means which paper I have to include, which paper I have to exclude. So the inclusion criteria was peer-reviewed articles published between 2015 to 2023. And the paper will be related to healthcare sectors and only English papers written in English. The exclusion criteria was non-peer-reviewed sources and also duplicate papers, right? And non-English articles excluded and incomplete studies. So the main technologies used in healthcare cyber physical system was AI. This is to predict disease and smart diagnosis. Internet of Things is using to connect all these smart healthcare devices. For medical data storage and processing, we need cloud computing system. For real-time local processing, we need edge computing. In order to process large medical data, we need big data analytics. So this paper is basically explaining the current healthcare system, how we can convert the current healthcare system into a smarter system by incorporating artificial intelligence and IoT. The main benefits of implementing AI and IoT was real-time monitoring was possible. Faster diagnosis again is another advantage. Remote healthcare is possible, and also we can improve the decision making. The important research concepts mentioned was through a systematic method, through a structured method, research papers was collected and analyzed. So in the screening process, the relevant papers was selected, and in the eligibility sector, the quality and relevance was checked, and also peer review will validate the experts' research. So in this paper was explaining These researchers studied systematic and scientific method. They have analyzed the healthcare CPS studies. With the help of Prisma methodology, they have filtered thousands of papers and selected only high quality relevant papers. Through this, the healthcare CPS technologies, challenges, applications, and future research directions was accurately identified. Prisma methodology is a systematic literature review to improve the quality of the literature review. Researchers structured filtering and eligibility process. They will be selecting the relevant healthcare CPS research papers by utilizing the keywords such as AI, IoT, cloud, edge computing. Uh, we can select appropriate research papers, and also we can convert the existing healthcare systems into a smart healthcare systems with the help of these technologies. So here in this page explaining about healthcare cyber physical systems, classification of technologies used in healthcare cyber physical system. So the main technologies in healthcare, HCPS means healthcare. HCPS means healthcare cyber physical system. So we have computing platforms, then we have IoT, then we have AI, artificial intelligence, we have a digital twin, and we have blockchain. Computing platforms. In order to process the healthcare data, we need computing infrastructures, right? So we need cloud computing, we need what is cloud computing? So cloud computing means we need to store the medical data through the internet servers. That is what is called a cloud computing. The advantage of cloud computing is that we can store a large amount of data, and also we can remotely access the data. We means the doctors. The doctors can access the data remotely. Cost reduction, but we need edge computing also, because the problem of cloud computing is latency. In order to avoid those situations, we need edge computing. That means processing will be near to the data source. The main advantage of edge computing was low latency comparing with cloud computing, faster response, and energy efficiency. We need Internet of Things. That means all the healthcare devices are connected through the internet, so that remote health monitoring is possible. Smart ICU, ECG monitoring, sensor-based systems, etc. So we need different sensors, such as IoT sensor types. We have wearable sensor as well as implantable sensor. For example, smartwatch is an example of wearable sensor. Pacemaker sensor is an example of implantable sensor. Then coming to the AI, artificial intelligence, this will improve the decision making process. The different technologies was machine learning, right? So by analyzing the data of the patients, the system will predict the disease. Examples will be deep learning, medical image analysis, then reinforcement learning, intelligent healthcare automation. Then another one is robotics in AI. That means, the one example is old age patient support. That means assistive living robots, right? That means the robot will be helping in working in old age homes, or The robot is supporting old age patients. Then assistive surgery robots, that means surgical robots, that means robot will do the surgery, that means robotic surgery systems, and the robot will be exactly similar to human beings, called humanoid robots, that is for again for healthcare assistance. Another sector is a digital twin. That means this will be representing the exact virtual digital copy of the physical healthcare systems, the exact virtual digital copy of the physical healthcare systems. Patient personalization, surgical planning, medical device simulation, drug development, smart hospital infrastructure. The importance of digital twin was by analyzing the real patient system simulation, we can predict monitoring and testing. Then blockchain, this is a secure distributed database technology for secure data sharing, health data management, interoperability, pharmaceutical supply chain, remote patient monitoring, health insurance claims. Then cloud computing. So cloud computing, I have already mentioned. In healthcare systems, there is a huge amount of data will be generated. So we need to store, process, and sharing those data with the help of cloud. So in cloud architecture, we have different layers starting from the data collection. The sensor will collect the data. And the second layer will be processing. The data cloud server will analyze it. And the application layer will be layer number 3. The doctors and hospitals will access the result. And next is interoperability. I have already mentioned what do you mean by interoperability. Different healthcare devices, the communication capability between different healthcare devices. This interoperability is very much required because in hospital systems they will be using multiple systems such as, and these systems will be communicated properly. So interoperability is another issue. Security importance, healthcare data is highly sensitive. So encryption, authentication, secure communication, everything is very important. Smart healthcare infrastructure. So combining these technologies, HCPS technologies, we can convert the healthcare environment into a smart healthcare environment. That means automated monitoring, real-time alerts, intelligent diagnosis, and remote healthcare. So coming to page number 9, this paper is mainly explaining the cloud computing in healthcare CPS, then edge computing, what are the security and privacy mechanisms, FPGA based architecture, energy efficient smart healthcare systems. So cloud computing in HCPS. Why cloud computing is needed? In healthcare systems, generating a huge amount of patient data such as ECG data, MRI scans, X-ray images, sensor readings, patient records, etc. So cloud computing will helps hospital to store the data because huge amount of medical data is generating. Cloud computing will helps the organizations to the doctors to remotely access the patient data, and interoperability. Different hospital systems will communicate properly. Scalability. So cloud computing will help in data storage, remote access, interoperability, and scalability. Still, This cloud computing is having some challenges such as security risk, privacy concerns, and latency. Then another one is called a fog or edge computing. So this edge computing means do not sending the data to the cloud. So data will be sharing to the local device. This is what is called edge computing and process the data in the local device. Data is not sending to the cloud. So processing the data near to the data source is what is called edge computing. So the advantage will be faster response than cloud computing. Delay, we can reduce the delay, and also the energy consumption will be lower. Better reliability. Even though just imagine if there is a failure in network failure in uh, in cloud computing, it will affect, right? But if we have the local device, so even though there is a problem of network failure, the local processing will work. So reliability will be more in edge computing than cloud computing. FPGA based architecture, field programmable gate array. This is a hardware architecture to program. The purpose of FPGA based architecture was in healthcare was high speed processing and reconfigurable computing. The features will be flexible architecture. So based on the system requirements, this can modify. The performance will be very high because this will process large healthcare data, and also it is energy efficient. So this will be very much useful in battery powered medical devices. Wearable medical device, the best example will be smart watches, ECG wearables, blood pressure monitoring devices. The benefit will be continuous monitoring, and the system will provide real time alerts, and also remote healthcare is possible with the help of this uh, wearable medical devices. There are so many benefits, but still the possibility of cyber attacks, data theft, unauthorized access, network attacks are the security and privacy issues facing. So what are the solutions? What are the suggestions to avoid those situations? Data encryption, that means in a coded format that will protect the data, and authentication, so only authorized users can access the platform. Then authentication is another advantage. Then cryptographic techniques, it will ensure the secure communication. SACA fork framework. So this paper is also mentioning a special fork based healthcare framework. The main purpose is that the healthcare data will processing will work securely. The main features will be secure communication, lightweight encryption, reduced overhead, efficient authentication. Energy efficient computing. So in healthcare devices, they all are battery powered devices. So energy efficient is very much important. So dynamic voltage scaling, this will reduce the power consumption. Intelligent resource allocation. So processing resources will efficiently manage. Collaborative machine learning. Different healthcare devices combined to form learning. The benefits will be distributed intelligence, faster analysis, and better prediction. By incorporating the advanced computing technologies, we can convert the healthcare sector into a smart healthcare sector so that we can provide smart healthcare services to the society. So cloud computing will give the storage, edge or fog computing will give the feature of real-time processing, improve the real-time processing. FPGA will give high-speed processing by monitoring the wearable devices continuous. This continuous monitoring will be possible with the help of this wearable devices, and also the security frameworks will protect the patient data. So modern healthcare systems having multiple technologies, advanced multiple technologies integrated, such as cloud computing, edge computing, FPGA, wearable sensors, and secure encryption. So all these systems will convert the healthcare systems into faster, secure, reliable, and energy efficient. The future of smart healthcare systems will become the main areas will be security, real-time processing, and energy optimization. So this page is explaining advanced HCPS, healthcare cyber physical systems architectures and AI-based healthcare. So this page is basically explaining edge or fog layer healthcare architecture, big data analytics in healthcare, AI-enabled healthcare HCPS, that means HCPS, IoT-based healthcare frameworks and machine learning applications. Edge or fog layer architecture. What is this? Fog layer means there is a intermediate processing layer between cloud and the healthcare devices, what is called a fog layer. So the main purpose of this fog layer is to improve the real-time healthcare processing. The benefits was low latency, even though the situation is an emergency situation, it will give a faster response. Local processing is possible because the processing will be happening near to the data nearby devices. And also critical conditions, the patient critical conditions quickly detect and take faster decisions. This will reduce the cloud dependency. Even though we will be facing some internet failure, local systems will work. So this will reduce the cloud dependency. Remote patient monitoring, ICU monitoring, smart emergency systems are the healthcare use cases mentioned. The next one is called big data analytics. So in healthcare systems, they will be generating huge amount of data. So we have data from different sources, multiple sources. For example, wearable sensors, electronic health records, medical imaging, hospital databases. That means in healthcare systems, they will be handling a large amount of data. Large amount of data will be generated. So the purpose is to handle those large amount of data. We need big data analytics to predict the disease, take clinical decision support, patient classification, treatment optimization, etc. So Hadoop is what is called. I have mentioned in healthcare systems, a large amount of data will be processed. So Hadoop is a distributed computing platform to process large amount of healthcare data. So the main advantage is that parallel processing is supporting. Also, handling large amount of large scale data handling is possible, and also faster computation. Then AI enabled HCPS. This section will be explaining AI healthcare, how this will integrate with the CPS, different technologies such as machine learning, deep learning, neural networks. In machine learning, this will analyze the medical data and identify the patterns. Deep learning will recognize the medical image, and with the help of neural network, complex disease will predict. Remote, again, AI applications, remote patient monitoring, medication management, surgical assistance, disease diagnosis. Faster diagnosis, improved accuracy, and reduced human error will be the benefits of artificial intelligence. In this cyber physical systems, we have healthcare professionals and we have machines. So human machine interaction. So there will be a proper human machine interaction. That means interaction between healthcare professionals and smart systems. For example, smart monitoring dashboards, robotic surgery interfaces, voice controlled healthcare systems. IoT based framework. IoT based healthcare frameworks will improve the patient monitoring. Here it is mentioned WBAN, Wireless Body Area Network. This is a wearable sensor network in a body. The components will be sensors, communication network, data processing unit. So the function will be real-time monitoring, emergency alerts, continuous health tracking. Healthcare sensor systems, heartbeat sensors, blood pressure sensors, temperature sensors, oxygen sensors. These sensors will collect data from the patients continuously. So security and privacy issues in this healthcare IoT systems handling large amount of sensitive data, patient sensitive data, right? So security is a major factor. Data leakage is one major challenge. Unauthorized access, cyber attacks. So the solution will be encryption, data encryption, secure authentication, access control. So in healthcare cyber physical systems, AI, big data, IoT, edge or fog computing, everything will be integrated and convert the system into a smart healthcare ecosystem. So the wearable sensors will collect the patient data and AI will analyze it, and big data platform will process the large scale processing, and IoT frameworks will give the real time monitoring. So in this paper, they are explaining a table, right? This is a comparison table where this will be comparing different healthcare cyber physical system. There is a comparison. This shows a comparison. So we have different research papers and its contributions, testing method, description, etc. Okay. So this is a comparison. Okay, this is a of overview of research studies of computing platforms and solutions for healthcare cyber physical systems. So this row, actually this each row representing one research paper, and each column will represent Each column will represent the specific feature. So we have a reference number, and we have the year, that means the paper published year, starting from 2015 to 2023. And the basic idea, what was the basic idea, then problem addressed, right? So which problem they are trying to solve, and computing platform, what platform they used, for example, cloud, fog, edge, or hybrid. So what platform they used, and technology, what are the technologies they used, AI, IoT, blockchain, machine learning, and what are the tools they used, framework, software tools, algorithms, etc. So here we have some tick mark columns. This represents in that specific paper, this particular feature is supporting or not. For example, big data storage, scalability, interoperability, latency, bandwidth, security, energy consumption. For example, what is the scalability? Okay. So even though the system will work in small setups, small healthcare setups, if we will be trying to implement this in large healthcare systems, will the system will work? So this is what is called as scalability. Then interoperability means we have different systems, so we need a proper communication between all the systems, that is required. Then security issues. Uh, what about the patient data protection? Then energy efficiency. Okay, what about the power consumption? Is it less or more? Then another one is called a mobility, right? Wearable or mobile healthcare support. Then cost efficiency, low cost implementation is possible or not. So we have different computing platforms compared, such as cloud computing. The main advantage of cloud computing is the large storage, remote access is possible, and also cloud computing will support the scalability. But the disadvantage will be high latency and security risk because of the uh, because of the storage in the internet. Fog computing means there is a local layer between cloud and devices. So the advantage will be faster response and a reduced delay, and also better real-time processing. Edge computing means processing will be near to the data source. This will avoid the latency, and energy efficiency will be more, and the emergency response will be faster than the cloud. The different technologies compared was IoT, AI, machine learning, blockchain, big data. So the healthcare applications mentioned was remote patient monitoring, smart ICU, wearable healthcare, emergency healthcare. So the major observations from this table was the most papers focus on IoT integration, cloud-based healthcare, real-time monitoring. Common missing features was complete security, lack of unified standardized architecture, full interoperability, energy optimization. So the importance of comparative analysis is that this will be helping the researcher to identify what are the best technologies, and also the researcher can understand the research gaps and also improve the future system. So the overall meaning of this page is that different HCPS using different technologies and architectures. Cloud, fog, edge, IoT, AI, blockchain will improve the healthcare systems, but still the system will be facing issues such as security, interoperability, latency, energy efficiency. So this comparison table will show the overall status of the healthcare CPS research. So majority of the systems, smart monitoring and remote healthcare is supporting, but we need a fully secure, scalable, interoperable, and energy efficient healthcare architecture. Again, this is a future research challenge. So future HCPS systems combining multiple technologies and developing a smart healthcare ecosystem, intelligent and smart healthcare ecosystem. So again, we will be continuing the big data frameworks in healthcare. I have already explained the importance of big data because it will be generating huge amount of medical data. So to such as patient records, sensor data, ECG signals, blood glucose data, MRI and CT images. So big data framework means data storage, real-time processing, medical analytics and decision support. In cloud-based healthcare framework, having architecture components such as sensors, cloud servers, and healthcare applications. The advantages will be remote accessibility, scalability, and real-time communication. Distributed computing architecture will helps the system faster processing, better reliability, and load balancing and high availability. The technology mentioned here was Kafka, real-time data streaming platform, Spark, fast big data analytics engine, Storm, real-time distributed computation, no SQL databases, large scale flexible data storage. Without any delay, real-time healthcare analytics is required, right? So without any delay, the doctors should detect the patient conditions, critical patient conditions, ICU monitoring, emergency alerts, disease prediction, smart diagnosis. The main components of IoT-based HCPS having different components such as we need sensors, wireless sensors, communication networks, data analytics engine, cloud platform. The function of IoT HCPS will be continuously monitoring the system, remote healthcare, and intelligent alerts. Uh, Diabetes patient monitoring system is discussing in this paper. So the sensor will measure the glucose, data will be sent through wirelessly, and cloud will process it. Doctor receives the alerts. So the benefit will be without any. This is the main benefit will be non-invasive monitoring, continuous glucose tracking, early emergency detection. This paper is also explaining AI and analytic systems, supporting the systems, medical decisions, risk prediction, uh, classification of diseases, personalized treatment, medication monitoring. So the data storage and security and privacy issues. For that, data encryption, authentication, secure cloud communication will be the solution. Huge data volume will be handling. This is one of the major challenge, and real-time processing complexity is another challenge. Interoperability issues, privacy concerns. So this table is showing IoT HCPS frameworks. So again, we have a reference number, and we have a type. That means the healthcare framework type. Then the title of the framework. Then after that, the description, how that framework is working, right? How this framework is working, and the testing method. Then its contributions, and this is applied to real study. So 3D HCPS Intensive Care Service Framework. This is for ICU patient monitoring. The main feature will be remote monitoring so that the doctors can remotely monitor the patients. Sensor-based monitoring because it includes sensors, right? So the vital signals will continuously collect and real-time observation. So emergency situation will detect and the contribution will be improve patient observation and reduce delay. Cloud IoT CPS diabetes prediction framework. So this framework is used in diabetes prediction and monitoring. So the technologies used will be cloud computing, IoT sensors, predictive analytics. This is for accurate diabetes prediction and better monitoring. Then IOMT framework for real monitoring, Internet of Medical Things. So the medical devices will be connected through the internet. The feature will be real-time monitoring, sensor integration, smart alert. The contributions will be high energy efficiency and improved communication. Real-time healthcare system for pandemic support. This is the framework to help in pandemic situations. Again, remote monitoring, social distancing support, emergency alerts. Safer healthcare during the pandemic is the contribution. Then cognitive cybersecurity framework. Healthcare systems, it will protect from cybersecurity, cyber attacks, AI-based threat detection, intelligent security monitoring, risk prediction, and the contributions will be improved security, better privacy protection. Medical information security framework. Authentication, secure data access, encrypted communication, and a contribution. Portable health framework. This is for portable wearable healthcare systems. Wearable sensors, mobile monitoring, wireless communication will be the features. Continuous patient tracking and remote healthcare access are the contributions. Big IoT CPS healthcare data analytics framework. So this is a framework to analyze big healthcare data. So the technologies will be big data analytics, cloud platforms, IoT networks, large scale medical analysis, faster healthcare decisions. Low latency, real-time analytics, reduced bandwidth usage. So the observation from this table is the author is comparing different papers so that explaining different frameworks. And from this comparison, the author will be able to understand what are the common features in majority of the frameworks that includes IoT, real-time monitoring, cloud computing, remote healthcare. Still, there are some common issues such as security challenges, interoperability issues, energy consumption, and scalability limitations. So figure number 6 is showing IoT HCPS, Internet of Things, Healthcare Cyber Physical System applications. So the main IoT HCPS applications will be remote patient monitoring, medication management, telemedicine, and hospital asset tracking. So remote patient monitoring, as you already know, the system is to monitor the patient even though the patient is not available in the hospital. The system to monitor the uh, patient inside the hospital, right? So one of the best example will be during the COVID-19 situation. So that in that situation, remote healthcare is the only solution, right? And smart home-based patient monitoring. With the help of sensors, doctor will monitor the patient. ECG monitoring, continuously analyze the heart signals, right? So the benefits will be continuous monitoring, reduced hospital visits, early emergency detection. Medication management means this system will help the patients to take medicines on time, right time. Automated pill reminder, pill dispenser systems, medicine box with the dose delivery. So the sensor and software will track the patient medicine schedule. The benefits of this medication management will be improved medication adherence, reduced human error, better elderly care. Then coming to telemedicine, doctors and patients will connect through the internet. So that healthcare system is what is called a telemedicine system. So the applications will be rehabilitation, fall detection. Uh, so for example, if elderly patients will fall, it will give an automatic alert. Then virtual orthopedic assistance, remote orthopedic monitoring. So the benefits will be remote consultation, faster medical access, and reduced travel. Then hospital asset tracking. So this system is to monitor the hospital equipment and resources. For example, medical supplies, drug distribution tracking, RFID based tracking. Then the benefits will be managing the equipment. This will reduce the equipment loss, and also this will helps for faster hospital operations. So, smart medication systems. So this system will check whether the patient will be taking the medicine right time or not. So the sensor will detect the pill usage, and the system will send a reminder. Doctor or the family will get an alert. So the technologies mentioned was RFID, IoT sensors, cameras. During the COVID-19 time, uh, telemedicine, and during the COVID-19 situation, this telemedicine and this remote healthcare was common, right? So during this COVID-19 situation, this reduced the physical comfort, remote diagnosis, and home-based monitoring. In order to analyze the healthcare data, we need to use machine learning technology. With the help of machine learning, we can predict the disease, patient monitoring, and emergency detection will be possible. Still, this system is facing some challenges such as privacy concerns. Another big challenge is the data set. So training data set is very small. So again, this will affect the machine learning accuracy, right? So healthcare systems will face some cyber security issues, cyber attacks, so security risk. So this page number 15, this is explaining sensor-based IoT HCPS applications. Why sensors are important? Because the sensor will continuously monitor the patient body conditions such as temperature, heart rate, blood pressure, blood motion, oxygen level, etc. So with the help of this sensor, continuous monitoring, early disease detection, emergency alerts are the benefits. Using RFID based healthcare systems with the help of radio frequency identification. This is to track the medical equipment, drug monitoring, patient identification, hospital asset management. The advantages of using RFID will be faster tracking, reduced human error, and automated monitoring. In smart healthcare monitoring systems, multiple technologies will integrate, such as sensors, RFID, AI, cloud computing, fuzzy logic, etc. The benefits will be real-time inventory control will be possible, supply monitoring, and improved healthcare operations. So we have a table showing here, table number 5, sensor-based IoT HCPS applications. So we have sensors used, right? Networks, algorithms, and applications. So common sensor applications will be ECG monitoring, smart wearable systems, wireless monitoring, and remote patient tracking. Then enhancement of healthcare cyber physical system with artificial intelligence. How artificial intelligence will help the CPS systems and convert the system into a smarter system. Machine learning, deep learning, reinforcement learning, and robotics. So through these technologies, the healthcare systems will be converted into smarter. Personalized medicine is one of the main use of applications of artificial intelligence. That means patient specific treatment and anomaly detection. Abnormal patient conditions will be detected. Healthcare data protection, cyber security, and AI will detect the disease early. Because of that, the treatment will be improved. Machine learning algorithms. So support vector machine SVM for disease classification, K nearest neighbors for pattern recognition, and neural networks for complex medical prediction. COVID-19 AI detection system, it will collect patient data, and after conducting an AI analysis, it will classify the disease and it will predict the severity. So the advantage is that faster detection, early treatment, and better pandemic management. This AI, with the help of this AI, it will reduce the human error by giving automatic alerts, smart decision support, and intelligent diagnosis. So we will continue the remaining chapters within 5 minutes. So this page is mainly explaining what are the different algorithms, machine learning algorithms used in healthcare. And also this paper is explaining remote patient monitoring systems, AI-based rehabilitation systems, abnormality detection, and deep learning and CNN models. What is the use of machine learning in healthcare? As I have already mentioned, a large amount of data is generating in healthcare. So these data will automatically analyze, and based on the analysis, the system will give predictions. That technology is what is called AI machine learning in AI. For that, using different algorithms such as SVM, support vector machine. This is for disease classification and prediction. K-nearest neighbors for pattern recognition and patient similarity analysis. Random forest prediction based on multiple decision trees. Decision tree means step-by-step decision-making model is what is called a decision tree. The purpose of these algorithms is to detect the disease, classify patients, and detecting any abnormality, real-time monitoring. So the cloud services will support the remote healthcare. The main functions of cloud-based healthcare services will be data storage. The large amount of healthcare data, patient data will be stored, and then after that, analyzing the data and real-time communication. The main advantage of cloud is remote access. This will improve accuracy, stability, and scalability. Security in healthcare systems. This healthcare systems handling sensitive patient data, right? So security is very much important. So for that, data encryption is required. Secure data transmission, authentication is required. The goal is to protect the patient privacy. So AI-based rehabilitation systems. This paper also explains AI-based rehabilitation systems. So after accident or stroke, it will support patient recovery. The role of AI is, movement analysis, exercise monitoring, performance evaluation. For that, the different technologies such as Kinect cameras for motion tracking, PCA, principal component analysis, data dimension reduction technique, logistic regression. This is a prediction model. The benefits will be better rehabilitation accuracy, continuous monitoring, and personalized therapy. Abnormality detection systems. AI systems will detect abnormal physiological conditions such as heart problems, blood pressure abnormalities, respiratory issues, etc. So the sensor will collect the data and AI will analyze it, and the system will generate an alert. Deep learning and CNN models. For image and pattern recognition, deep learning model is used. For medical image classification, normal versus abnormal detection, disease prediction. The benefits will be higher accuracy, faster processing, automatic feature extraction. Federated learning model. So in order to send the patient data to a centralized server, learning will be happening through local devices called a federated learning model. So the advantage will be better privacy, secure data handling, and reduced data sharing risk. Dataset and evaluation. Using different datasets, evaluate algorithms. The evaluation metrics mentioned such as accuracy, precision, recall, and F1 score. So KNN and SVM algorithms will show higher performance. So the problem mentioned here was small dataset problem. If the amount of training data is less, then the accuracy will be less. The AI accuracy will be less. So real-time complexity is another challenge. Continuous monitoring systems will request more processing power. Advanced AI systems need powerful hardware systems. So this page also explains AI security, workflow optimization, and robotics in HCPS. AI-based anomaly detection, cybersecurity in healthcare CPS, workflow optimization using AI, WBAN and healthcare communication, robotics in healthcare. AI-based anomaly detection means detect abnormal conditions. Using AI systems, by analyzing the patient data, it will detect the abnormal conditions of the patients. So for that, we can detect diseases early, so prevent critical situations, improve patient safety. Different AI techniques such as position tracking, it will track the movements of the patient, it will monitor the movement of the patients, and also it will detect the abnormal health behavior, and based on that, it will predict the future medical risk. The benefits will be faster emergency response, reduced false alarms, and improved accuracy. Cybersecurity in healthcare CPS, one of the main thing is that confidentiality. We have to store the data because the patient data are highly sensitive. So storing those highly sensitive data is very crucial. And then integrity. Uh, do not convert the data into unauthorized availability. So the data will be available for to the authorized peoples, right? So the threats will be cyber attacks, data breaches, unauthorized access. Security solutions, encryption, then secure authentication like Google Authenticator. Machine learning based security. AI will detect any suspicious activities. AI-based workflow optimization. This will helps to manage the hospital operations efficiently, like resource allocation, staff scheduling, patient flow management, operational efficiency. This will reduce the waiting time, better resource usage, and improved healthcare quality. WBAN system, that means wireless body area network. This is the communication network between wearable sensors inside the body. This will monitor continuously real-time data transmission, emergency alerts. The main problem is energy consumption because majority of the wearable devices are battery-powered devices. Communication reliability, privacy concerns. DIGP WBAN scheme. So the purpose of this is WBAN communication efficiency, improve the WBAN communication efficiency. The feature will be low energy consumption, better data transmission, and a reduced communication burden. Privacy concerns still exist, right? Robotics in healthcare. In this section, explaining about robotics in healthcare. What is healthcare robotics? Surgical robots is an example. That means robot will perform precise operations. Rehabilitation robots that will support patient recovery support. Assistance robots means hospital support. The robot will do hospital support tasks. Remote medical robots for remote consultation and treatment. The benefits of robotics will be high precision, reduced human error, and faster procedures than human beings, plus better patient care. By combining AI and robotics, by integrating AI and robotics, we can create an intelligent healthcare system. For example, autonomous healthcare robots, smart surgical assistants, intelligent patient monitoring. So this is again a detailed comparison table. This table shows AI-enabled healthcare cyber-physical systems. Different papers will be comparing. So the purpose of this table is to compare different healthcare systems. Okay, which algorithm is using, and how many healthcare support and healthcare applications the system will support, and what is the performance, any security problems, and also how is this support real-time monitoring. Every row every row in this paper is sorry, every row in this table is showing a research paper, and every column that represents the specific technical feature. So we have REF. REF represents the reference number that to identify the research paper, and the title one column is representing the research work title, and then algorithm. That means AI or machine learning techniques used. Then techniques, system implementation methods. Then another one is performance. Then accuracy, that represents the AI prediction accuracy. Security, that means data protection support, and also real-time monitoring support will be mentioning in real time. Then scalability, will this support in large healthcare systems? In this table, comparing different so many different algorithms, comparing, such as SVM, support vector machine. This is to classify disease and predict the disease. High accuracy and good for medical classification. K nearest neighbor, KNN. This is for patient similarity and patient recognition. Simple implementation and effective prediction are the advantages. Random forest RF, uh, prediction using multiple decision trees. Better stability and reduced overfitting are the advantages. Deep learning or CNN for medical image analysis, disease detection, very high accuracy and automatic feature extraction. The application types, such as remote patient monitoring, disease prediction, ECG analysis, rehabilitation monitoring, smart diagnosis, emergency detection, also mentioned. Performance analysis, this table is also comparing the performance of different systems such as accuracy, precision, recall, and F1 score. So most AI systems is having high accuracy, fast prediction, and efficient monitoring. Comparing the security features also, encryption, authentication, secure communication, access control. So comparing these papers, some papers, they have provided strong security, but many of the systems are still vulnerable. Then real-time monitoring capability for faster emergency response, continuous monitoring, immediate alerts. The challenges will be high processing requirement, network dependency, and the scalability analysis. Scalability analysis means will the system will be able to handle large hospital systems. So many systems already conducted small scale testing, but large scale deployment still they will be facing challenges. So the key findings from the table will be author compared different papers, and the strength of existing systems will be high accuracy, smart monitoring, remote healthcare support, fast disease detection, but still there are some problems such as security issues, limited scalability, privacy concerns, energy consumption. The importance of this comparative table will help to select which one is the best algorithm, and also the researcher will be able to understand the limitations and also improve future HCPS systems. So this page is explaining AI-based robotics in healthcare, rehabilitation and assistive robots, surgical robotics, social and autonomous robots, digital twin in HCPS. What is AI-based robotics in healthcare? The main goal is to improve patient healthcare, reduce human error, and increase the precision, and also supports the healthcare staff. Rehabilitation robots supports patient recovery, such as physical therapy assistance, movement recovery, stroke rehabilitation. The role of AI is to analyze the patient movements and personalize the therapy. So the main advantage is that better recovery monitoring, improved therapy accuracy, reduced therapist workload. Faravo's robotic system. So the purpose is to support elderly and disabled patients. The feature will be personalized assistance, activity monitoring, emergency detection. The technology used was sensors, AI algorithms, and decision-making systems. Coming to the surgical robots, this is the main technology used in surgical robots, in healthcare. So this surgical robots will helping doctors assisting surgeons, performing precise operations. This will improve the accuracy of the surgeries. The advantage will be smaller incisions and faster recovery, reduced blood loss, and improved precision. Instrument tracking in surgery. This paper also explaining surgical instrument tracking. Accurately tracking the surgical tools because uh, smaller instrument shapes, real-time tracking complexity. AI, deep learning model instrument will improve the recognition. Autonomous and social robots. These robots will interact with patients, voice communication, and these robots will monitoring elderly patients, COVID-19 assistance. The benefits will be reduced human contact, safer pandemic operations, continuous assistance. This paper also explained robotic sensors in healthcare monitoring called AI-based robotic monitoring, such as collecting the data, patient observation, emergency alert generation, and real-time communication. Digital twin in HCPS. This Digital twin means it is the virtual digital replica of the physical healthcare system for the purpose for simulation, monitoring, prediction, and optimization. Healthcare applications will be smart hospitals, patient modeling, surgical planning, medical device testing. The benefits of digital twin will be real-time visualization, better decision making, reduced risks, and predictive healthcare. The challenge behind digital twin will be high computational requirement, data privacy issues, real-time synchronization complexity. So this page also explains the digital twin models in healthcare. As I have already mentioned, what is digital twin? It is the virtual digital copy of the physical healthcare systems. The main components will be real-time sensors, AI, data analytics, cloud computing, and IoT devices. So the purpose of digital twin is that the physical patient or system will continuously monitor and it will automatically update in the virtual model. We have a figure number 8 is showing digital twin model in HCPS. We have a physical world. So physical world represents the patient or medical device real environment, working in real environment such as patient, medical device, hospital facility, etc. Step number 2 will be sensor will collect the data. Sensor will collect the physiological data and data will be transferred through IoT and communication networks. Then digital twin will continuously synchronize. So in the virtual model, it will be updated, right? So we have two same systems. One is real and another one is virtual. So this virtual system that exactly represents the physical system is what is called a digital twin. So this digital twin continuously synchronize it. And after that, AI analysis. AI will conduct the predictions and simulations. System will give recommendations. That is what is called a feedback, decisions and feedback. For example, patient personalized care will be suggested from this digital twin. So this digital twin will provide patient-specific healthcare. So everything related to the patient will be analyzed by this system, such as, for example, the medical history, the body conditions, sensor readings, lifestyle data, everything. All the data related to the patient will be analyzed. So the main benefit of this digital twin will be personalized treatment, better diagnosis, early disease prediction, and continuous monitoring. So, for example, like we can say one example, cardiac patients. So the system will continuously monitor the patient, and the system will predict heart disease. Then coming to the surgical planning and training, digital twin. Uh, this is an important in surgical planning. That means before doing the actual surgery. So this digital twin is very much useful in surgical planning and training. Before doing the actual surgery, the doctor can do a virtual simulation. Like the pilots, they are working in flying simulator before operating an aircraft, right? So like that, this in digital twin, the doctors will do a virtual surgery, virtual simulation in digital twin. This will reduce the risk, and also this will provide better surgical accuracy, and the surgeons will get more trainings, because this is virtual. That means the doctor can practice more and more time, so that the patient will get optimal treatments. Virtual simulation, surgical modeling, AI based analysis, medical device testing. Okay, so again, this digital twin will support to test the medical devices. Before testing a machine with the patients directly, we can conduct that testing in this digital twin environment. We can conduct that test in a simulation environment. What are the applications mentioned here? RF induced heating analysis, MRI safety testing, device behavior simulation. The benefits will be safer medical devices, reduced testing risk, and faster product development. By integrating the digital twin and AI, this will support the predictive healthcare, so that predict the disease, treatment optimization, simulation based decisions, real time alerts. But still, this digital twin is facing some issues such as interoperability, because we have different systems. Integration is very difficult. Data privacy is another issue, because the patient data is highly sensitive, and also the system is handling large amount of data. So a digital twin should continuously process large amount of data. High computational cost is another problem, because the system needs AI and artificial simulation systems. They need powerful hardware. Importance of real-time synchronization. That is one of the major advantage of digital twin. The physical patient and the virtual model will continuously maintain the same state. Whatever be the state of this physical model, that same state will be represented in this digital model. So there will be a synchronization between physical system and the digital system. So real-time synchronization is very important. Why this is important? To predict the accurate results, reliable monitoring, and better clinical decisions. Again, this digital twin is used for so again, this digital twin is used for disease diagnosis. This technology is used in healthcare diagnosis. So that means in digital twin, this will create the virtual patient model. So with the help of that, we can predict the diseases, and also analyze the treatment effects. And this paper is also explaining, helping the doctors to diagnose the cancer. Again, the patient data will be collected, and by conducting AI-based analysis, doing a virtual simulation, we can predict the treatment response. So through that, early cancer detection is possible, personalized therapy is possible, better clinical decisions is also possible. Then drug development using digital twin. Using digital twin, This will be using to develop the drug to test medicines virtually. This will reduce experimental risk, and this also will improve the drug effectiveness. For example, cancer treatment drug simulations. So the main advantage will be faster drug development. It will reduce the cost, safer testing. Then coming to this digital twin is used in smart hospital infrastructure. For example, we can develop the virtual hospital simulation to improve the workflow, resource management, and emergency planning. The benefits will be this will improve the efficiency. This will also improve the better patient flow. This will reduce the operational cost, and also we can create the virtual replica of the virtual patient environment. The purpose The purpose is to simulate human body conditions, study disease progression, test different treatment strategies. Before doing the actual treatment, using this simulation, the doctors can analyze it. And another one is real-time data synchronization. So real patient and digital model will continuously synchronize to predict the data results accurately, reliable monitoring, and effective decision making. Blockchain enabled HCPS. Blockchain means this is a secure distributed digital ledger technology. The main features will be decentralization, transparency, security, and immutability. Blockchain applications in healthcare will be electronic health records, secure medical data sharing, healthcare transactions, smart contracts, improved data integrity, better privacy protection, reduced fraud, and secure communication. The challenges of blockchain will be high computational complexity, interoperability issues, large data handling, privacy concerns. By incorporating AI, digital twin, blockchain, we can convert the healthcare system into a future intelligent healthcare ecosystem. The combined benefit will be secure, intelligent healthcare, predictive healthcare, real-time smart monitoring, and personalized treatment. So figure number 9, this figure number 9 is showing digital twin domains in HCPS. So starting with patient personalized care. So this digital twin will provide patient specific healthcare for disease monitoring, risk prediction, treatment optimization, and remote patient support. The benefits will be better diagnosis and personalized treatment. Another one is this digital twin will be used in surgical planning and training. So the surgeons can do a virtual surgical simulation before doing the actual surgery. Because of that, the surgical risk analysis will be reduced. So this will be used as a surgeon training. This will improve the surgical precision, reduce the risk of surgical risk. Then coming to the medical device testing, this is for device performance analysis, safety testing, and simulation-based validation. This will helps for faster product development, and this will reduce the experimental risk. Another one is disease modeling and drug development. Cancer modeling, drug testing, therapy prediction for faster drug discovery and personalized medicine. For a smart hospital infrastructure to allocate the resource properly, hospital workflow analysis, emergency planning, equipment monitoring. The benefits will be better hospital efficiency, reduced operational cost. So this figure is showing the characteristics of blockchain. What are the characteristics of blockchain? So blockchain is a secure distributed digital ledger system. The main characteristics of blockchain will be decentralization. That means no single central authority. Transparency. That means all authorized users can verify the transactions. Data protect cryptographically, so security, it is secure. And immutability, strong stored records, it is very difficult to modify. Traceability, that means data history we can track. What is the role of this blockchain in healthcare CPS? Such as electronic health records, secure data sharing, access control, medical device security. This will improve privacy, reduce the data tampering, and a better trust. Smart contracts in healthcare. Automatic blockchain-based digital agreements is what is called as smart contracts in healthcare. Automated transactions, healthcare payments, insurance claims, faster processing, and reduced fraud. Blockchain for medical device security, authentication, encrypted communication, secure data exchange. Blockchain is used in pharmaceutical supply chain for drug tracking, counterfeit drug prevention, supply transparency. This will improve traceability, better inventory management, and secure distribution. So even though these are advantages, but the computational cost is very high, scalability issues and integration complexity, data privacy concerns are the challenges. But we have advantages: intelligent healthcare, predictive analytics, real-time monitoring, and secure data management. So this table is explaining what are the blockchain applications in healthcare cyber physical systems. So we have different blockchain frameworks, security features, privacy protection, smart contract support, and scalability and healthcare applications. Again, we have the reference number that represents the research paper number. Then its application, for example, healthcare application type such as remote monitoring, supply chain, EHR, medical data sharing, etc. And the blockchain type such as Ethereum, Hyperledger, multi-chain. Access policy, data access permissions, then transaction system, centralized or decentralized operation. Will this automatic blockchain agreement support smart contract? What are the issues addressed? Security, privacy, and scalability challenges. So here the blockchain types mentioned here as Ethereum. Ethereum, most popular smart contract blockchain platform for smart contracts, decentralized system, and secure transactions. For healthcare users, medical data sharing and patient records. Hyperledger, permission-based enterprise blockchain for high privacy, controlled access, enterprise security. Hospital networks, pharmaceutical systems are the applications. Multi-chain for private blockchain framework, fast transactions, permission management, and secure communication. Pharmaceutical supply chain. This paper also explaining pharmaceutical supply chain applications. The current pharmaceutical issues will be supply issues will be counterfeit medicines, lack of transparency, and poor traceability. Using blockchain, drug tracking, transparent transactions, supply chain verification was possible. This will improve the safety, better traceability, and reduced fraud. Remote patient monitoring using blockchain. Blockchain is using in remote healthcare systems because the patient data are highly sensitive. In order to secure sensor data, encrypted communication, decentralized storage, this will improve privacy, tamper resistance, and a secure remote monitoring. The digital agreement, automatic digital agreement in blockchain is called as smart contracts in healthcare to claim insurance, automated payments, medical record access. The benefits will be faster transactions, reduced administrative work, improved trust. But still, it is having some security issues such as privacy, scalability, transparency, and interoperability. So coming to this picture, figure number 11, that is showing comprehensive reference architectural model for HCPS in healthcare. So this is explaining how the healthcare cyber physical will work from end to end. So the main flow will be like this. The sensors will collect the data, right? And then communication network will transfer this data. And we have cloud or edge systems that will process the data. The AI will analyze it. And then after that, healthcare applications will make the decisions. On the top, we have a security layer, right? So we have encryption scheme, such as blockchain, uh, authentication mechanisms, right? Then secure networking, anomaly detection. The purpose is to make sure that the healthcare data is safe and secure for privacy protection, cyber attack prevention, and secure communication. Then we have a physical layer, right? A physical layer represents it is connected with the patient body, right? So we have different sensors such as ECG sensors, blood pressure sensors, temperature sensors, motion sensors. The purpose is for real-time patient monitoring. And WBIN is mentioned here, that is wireless. WBIN means wireless body area network. That communication network is used to connect the sensors in the body. The function is to monitor continuously real-time data collection and emergency alert generation. We have a communication layer, right? So in the communication layer, this will transfer layer data. So the technologies used mentioned as Bluetooth, Zigbee, right? Then Wi-Fi, LoRa, then RFID. The purpose is to transfer the sensor data to the server. So the important functions will be low power communication, long distance communication, and reliable data transfer. We have a data processing layer, right? So this will process the healthcare data. So we need edge computing, then fog computing, cloud computing, databases. The function is to store the data filtering, data aggregation, and real-time processing. Then we have data analytics and decision making layer. Here using the AI, machine learning, deep learning, neural networks, predictive analytics. The purpose is to predict the diseases, anomaly detection, decision support, risk analysis. Then finally, we have a presentation layer that will give the final healthcare services such as monitoring, rehabilitation, smart home predictions planning. So the users such as doctors, nurses, patients, and administrators. The communication protocols such as IEEE 802.15.6, this is WBN communication standard. Then the purpose is that this will provide secure communication between wearable medical devices. This will use low power consumption, reliable transmission, and energy efficiency. The network topologies mentioned here was star topology because that represents central node communication model. For efficient energy management, cluster-based protocol is mentioned. Better scalability and improved communication efficiency will be the benefits. So here we have figure number 12 explaining WBAN routing protocols, right? So what is WBN? Wireless body area network. Wireless body area network. That means in the patient body having different sensors, right? So there is a proper communication between these sensors. For that, we need WEN, wireless body area network. A routing protocol. The routing protocol means the sensor will efficiently transfer the data. So the different parameters considered was energy consumption, delay, reliability, and data transmission quality. The type of routing protocols mentioned was a temperature-based protocol. This is related to the temperature. That means overheating. Avoid sensor overheating. Then because this is wearable devices, okay, so temperature control is very important. So for that, we have a temperature-based protocol. This will reduce the heat generation and improve the patient safety. Then another one is called the quality of service protocols, QoS. So that means priority, critical healthcare data transmit priority wise. For example, emergency ECG data will send first. So the benefit will be faster emergency response and reliable communication. Then another one is, power aware protocol. Okay, that means related to the battery usage, optimize the battery usage to get longer sensor lifetime and reduced energy consumption. Communication protocol, this is very much useful in healthcare system. From the physical layer to the cyber layer, transferring the data. Different technologies such as Bluetooth, Zigbee, RFID, NFC, LoRa, 5G, etc. The function of the communication layer is to transmit the data, connectivity, and remote access. Choosing communication technologies based on the requirements, healthcare application can choose the communication technology. When selecting the communication technology, we have to consider different factors such as data volume, communication range, energy efficiency, and reliability. For example, Bluetooth, we can use Bluetooth for short range and LoRa for long range. 5G for high speed real time, we can use 5G. So based on the applications, we can choose the communication technologies. Cyber layer. This is an intelligent processing layer of healthcare CPS system. The main function will be data processing, analysis, decision making, and storage management. The processing will be happening near to the sensor itself is what is called edge computing. So the benefit will be low latency and a faster response, reduce the cloud dependency. Fog computing, it is the immediate layer between edge and cloud. So this will support distributed processing, better scalability, and improved real-time performance. Cyber layer will be using AI algorithms for real-time analytics, machine learning, predictive analytics, and risk detection. Security importance, security goals, integrity, availability. What are the threats mentioned, such as the data breaches, unauthorized access, network attacks? So in this table is explaining what are the characteristics of mostly used wireless technologies. We have different columns such as technology, standard, frequency band, then range, data rate, power consumption, topology. So for example, Bluetooth. So Bluetooth is used for short range communication, right? And low power usage, moderate data speed. Healthcare uses wearable devices, smartwatches, patient sensors. This will be energy efficient, easy connectivity, and but the limitation will be this can be used only for limited range. Then we have Zigbee. Zigbee is for low power consumption, mesh networking, reliable sensor communication. In healthcare uses, WBAN system, smart sensor network. The advantage will be long battery life and good scalability. Then we have Wi-Fi, high data speed, internet connectivity, large data transfer. In hospital networks, Wi-Fi is using, right, for telemedicine, medical imaging. The main advantage will be fast communication, wide availability, but the limitation will be high power consumption. And another one is called LoRa for long range communication, low power usage, low data rate, for remote healthcare monitoring, rural healthcare systems, wide coverage and energy efficient. Cyber layer analytics. This is the intelligent processing center of the cyber layer healthcare system. The main function will be data mining, uh, predictive analytics, pattern recognition, machine learning. Based on that, take appropriate decisions, improve diagnosis and personalized treatment. Simulation and optimization techniques. Simulation means this will create a virtual healthcare scenarios. For example, disease progression analysis, treatment testing, emergency scenario planning, optimization techniques. For example, resource allocation, scheduling optimization, energy optimization. Statistical analysis such as regression analysis, hypothesis testing, correlation analysis. This is to identify the healthcare trends and its relationships. Presentation layer that represents the end user, display the healthcare information for doctors, nurses, patients, administrators. Data visualization, real-time monitoring dashboards, alerts and notifications, decision support interfaces, so that they can take faster clinical decisions, improved user understanding, better healthcare management. So overview of HCPS security. This will be explaining the security architecture. So the main goal of this table is to compare different components of different layers, right? For example, physical layer. So this physical layer means this is connected with the patient connected devices. For example, sensors, actuators, wearable devices, medical equipment, etc. So some security issues such as, for example, device tampering, unauthorized access, physical damage, node capture attack will happen. So the solution will be secure authentication, biometric access, encryption, and access control. In communication layer security, this layer will be transferring the data. The components will be wireless network or wired network communication channels. Again, the security issues will be data privacy during the transmission, communication interception, eavesdropping, replay attacks. Secure communication protocols, cryptographic algorithms, digital certificates are some solutions. And the third layer will be cyber layer security, such as cloud servers, fog or edge devices, databases, analytic systems. The security issues will be data confidentiality, data integrity, malware attacks, denial of service, regular backups, intrusion detection systems, firewalls, AI-based threat detection we can use. Finally, the presentation layer security. This will be dealing with visualization tools, user interfaces. What are the security issues? Unauthorized access, session hijacking, cross-site scripting. So the solutions will be secure coding practices, multi-factor authentication, role-based access control. So what are the cyber security threats mentioned, such as malware, phishing, injection, replay attacks, and DOS attacks? Why this healthcare is vulnerable? Because in healthcare systems, they will be storing huge patient data and real-time communication. Multiple devices are connected, so this will be targeting the cyber attack. So this paper also explaining blockchain healthcare will improve the security. So implementing HCPS in cardiovascular disease management. What is the cardiovascular disease? This is disease related to heart. So for example, heart attacks, stroke, hypertension, etc. So in HCPS, the role of cardiovascular disease management will be continuous monitoring, real-time tracking, so that we can detect the risk early. The doctors can take decisions. So the doctors will get a support by utilizing this healthcare CPS system. So the sensor will measure the heart rate, blood pressure. Blood pressure sensors will measure the blood pressure. Activity sensors. So early diagnosis is one of the benefit. Better patient monitoring, reduced hospitalization. So this is an HCPS framework for cardiovascular disease management. So this will be explaining, we have a patient census, right? So then AI processing, prediction, and dashboard visualization. So the main goal is to detect the cardiovascular disease early. Real-time monitoring, AI-based prediction, continuous patient care. So we have a data collection layer. So we have a different sensors such as ECG sensor, pulse sensor, it will measure the heart rate. Then wearable devices, the purpose is to collect physiological signals. Then streaming and data transfer, data collected. Once the data is collected, the system will continue to stream it. The different technologies will be using will be Kafka. This is a real-time data streaming platform. Then Azure IoT Edge. This is an edge computing platform. The purpose is that share the sensor data real time to the real-time processing system. Continuous data flow, fast communication, real-time analytics. Then signal pre-processing. So we cannot process the raw healthcare signals directly. So we have to do some pre-processing, such as noise filtering, then resampling, etc. Then from that, we have to extract the features such as heart rate variability, time domain features, frequency features, etc. Then features will be ranked and select the important features. All features are not equally useful. This will improve the accuracy, faster processing, reduced complexity. And we have a database layer, right? So Cassandra database, this is for to store large scale healthcare data. High scalability, fast data access and distributed storage. Then we have Edge AI frameworks. This will support local AI processing technologies such as TensorFlow Lite, ONNX, Open Neural Network Exchange, NVIDIA Edge AI. This is a high performance edge interface. The benefits will be low latency, fast decision making, and a real-time prediction. We have a cloud layer. This will handle model training and storage, train AI models, store healthcare data, and long-term analytics. Upload the model into the cloud, train the model, deploy model to the edge, and then we have a prediction engine. AI trained the model will generate the predictions. So predictions mentioned such as cardiovascular uh, risk prediction, abnormal ECG detection, early warning alerts. So the benefit will be this will prevent heart emergencies, improve diagnosis. Then finally, we have a dashboard layer. This will display the final healthcare information such as patient monitoring, prediction visualization, alerts, and notifications. Clinical decision support. This will be used by the doctors, healthcare staff, and patients. So here we have edge versus cloud processing. So edge processing that will give faster response, low latency and local processing. Cloud means large scale training, massive storage and advanced analytics. So what are the challenges? What are the major technical challenges we will be facing during this healthcare cyber physical, during the implementation of healthcare cyber physical systems? So here, as you can see, HCPS challenges. This is our central topic. So around it, we have identified the multiple challenge categories. So the main category, the main challenges will be interoperability, right? So the network load, security and privacy, resource management, quality of processed data, real-time responsiveness, accuracy and reliability, energy efficiency. Interoperability challenges means we have different healthcare devices and systems. There is a proper communication and integration will be required. Different communication protocols, right? Different data formats, different heterogeneous devices, scalability issues. Because different manufacturers, they will be using different standards. So using different systems, so there will be an issue of compatibility. Then network load and reliability. This system, this HCPS, healthcare cyber physical system using huge data, continuously transferring huge data. So network congestion, delays, packet loss, unstable connectivity. So the important factors will be fast data transfer, reliable communication, low latency. Because in healthcare sector, this is very critical. Even though a small delay is very critical, we need an immediate real-time response. Security and privacy challenges. Healthcare data are highly sensitive, right? So data breaches, unauthorized access, malware attacks, cyber attacks. So the required solutions will be encryption, authentication, access control, privacy regulations, etc. Regulations such as HIPAA, that means related to American Health Data Privacy Law. GDPR, this is related to European data. Then data integration and heterogeneity. So in healthcare systems using data from different sources. Different sources means wearable devices, sensors, electronic health records, medical imaging systems. That means the data is having different formats, inconsistent data, data quality problems. The result will be accurate using AI models. It is very difficult to predict accurate results. Resource management challenges. This HCPS is requesting high computational resources, high processing because of the high processing demand, right? Storage, high storage required, bandwidth consumption, energy consumption. So the goal is to utilize the resources efficiently. So the goal is to reduce the cost and provide better performance. Then coming to the quality of processed data. So healthcare decisions are very crucial decisions. So the professionals, the healthcare professionals will take the decisions based on the accurate data. So data validation issues, missing data, low data quality. So if the quality of the data is poor, then it will lead to a wrong medical decision. Real-time responsiveness. We need real-time healthcare support. So requirements will be low latency, high reliability, and fast processing. Because in emergency healthcare, that is requesting immediate health responses. Accuracy and reliability, highly accurate. Healthcare AI systems are highly accurate. So some problems will be sensor errors, signal quality problems, wrong predictions. We need reliable AI models and accurate sensors. Energy efficiency challenge. Wearable and the sensor devices are battery powered devices. So the battery life is very less, right? So energy harvesting, power management, these are the issues. The goal is that we need long lasting healthcare devices. So I'm concluding this. So we have discussed HCPS. HCPS means Healthcare Cyber Physical Systems. So that means this CPS is related with the healthcare. That means integrating AI, IoT, cloud, communication systems, everything will be combined and developed an intelligent healthcare ecosystem. So in this paper, the authors they have discussed different HCPS technologies and analyzed different applications they have mentioned, and also they have mentioned different challenges and also discussed about the future directions. The technologies mentioned in this paper was IoT, AI, machine learning, edge or fog computing, cloud computing, digital twin, and blockchain. Also, different healthcare applications were discussed, such as remote patient monitoring, disease prediction, cardiovascular disease monitoring, smart hospitals, surgical planning, rehabilitation systems, medical device testing. The key benefits of HCPS mentioned was real-time monitoring, improved diagnosis, personalized healthcare, faster decision making, better healthcare efficiency, reduced healthcare cost. The challenges highlighted was one of the main challenge was interoperability because we have different systems, compatibility issues, security and privacy is another problem because the patient data is highly sensitive data. Scalability is another problem. Resource management, data quality, cardiovascular disease management already mentioned. CVD is one of the major health challenge. So the role of HCPS is to monitor continuously, early detection, predictive analytics, emergency alerts. The result will be better patient outcomes. So future directions was uh, intelligent, autonomous, secure, real-time, patient-centered, predictive. That this will be the future healthcare systems. The future healthcare system will be intelligent, autonomous, secure, real-time, patient-centered, and predictive. Importance of AI integration. This paper is also emphasizing the importance of AI for automated diagnosis, predictive healthcare, intelligent decision support, risk prediction. Digital twin and the blockchain future is already mentioned. Digital twin means this is the virtual model of the physical systems, surgical planning, personalized healthcare. Blockchain will secure healthcare data, transparent transactions, and privacy protection. So finally, the overall idea of this paper is to convert the existing healthcare system into the traditional system into an intelligent, smart healthcare ecosystem using cyber physical systems by integrating AI, IoT, cloud, edge computing, blockchain, and digital twin technologies. So this will be helping the healthcare sector an automated, predictive, secure, and patient-centered. That's all. Thank you. We have more than 252 papers.